Let's start with alkenes. Alkenes having a molecular formula of CnH2n, it means with every one carbon we have 2 times of hydrogen. For example, here we have ethylene, which it's a common name for ethane, and its chemical formula is C2H4. We can see that in C2H4 we have 2 times more hydrogen than the carbon. Let's talk about alkynes. Alkynes are the compounds that have triple bonds in them. Their chemical formula is CnH2n-2. So whenever you see a chemical formula, you can find if the compound is alkyne by following this rule. Here you see an example of alkyne in the right picture. You see that it has a triple bond between carbon and carbon, and example is acetylene, which is the common name for the ethane. So you can see that the chemical formula for ethane is C2H2, and if you follow this rule, you can realize that this is going to be an alkyne when we have C2H2. 3D structure of alkenes is trigonal planar, and the structure of the 3D structure of the alkynes is linear. Please go back to Vesper theory to know more about how to find out the 3D structure of each carbon. Previously, we talked about the isomers in alkanes. Specifically, we talked about constitutional isomers. In the constitutional isomers, we have the same molecular formula, but the location of the bonds or attachments will be different. So that's making different isomers for alkanes. For the alkenes, we have also cis-trans isomerism. Another name for it is geometric isomerism. You can see that this compound has the molecular formula of C4H8, but if you pay attention closely to it, you see that the more weighted branches of the alkene is in one side of the alkene here. There are two CH3 in the one side of it and 2 hydrogen in the other side of it, in the upper side of it. But if you pay attention to the other compound here, which is again C4H8, so pay attention, both of them have the same molecular formula, but in this one, we have also alkene, the same as the other one in the left side, but the 2 branches that are most weighted are in the opposite side of this alkene or double bond. So this brings us to the cis and trans isomerism. We have the same molecular formula, but in one of them, the most weighted branch or branches will be in one side. We call it cis. We just write it before the name of the compound. And in the other one, the 2 more weighted branches will be in the opposite side of the double bond. And we write it before the name, and this is called trans. So this is called cis-trans isomerism. Another name for it is geometric isomerism. If you see also configurational isomerism, it also related to cis-trans isomerism. We already talked about that in alkanes that we should always find the longest chain. The same goes with alkenes and also alkynes. We should always first find the longest chain, but we should always include the double bond in the longest chain or in the alkenes. Okay, we should always include the double bond in the longest chain when we want to find the longest chain. And we should choose numbering from the side that gives the lower number to the double bond. So let's go to the reality. Here, I want to talk about first alkenes. Here you see that I have a line angle of this structure, which we have the same, the condensed formula here. So we first find the longest chain. Here I have the longest chain as a straight line, and we start from the right side here. Why? Because I reach the double bond sooner. So I start from the right side. Then we're gonna say I have 6 carbon, right? 1, 2, 3, 4, 5, 6. So it's gonna be hexene, because remember we should end up with E in alkenes. Hexene. Also, then we should emphasize what carbon has the double bond. We always emphasize on the lower carbon that has the double bond. We just pay attention because we know that the double bond is between the carbon 1 and 2. But I emphasize on the lower carbon. I mean the carbon that has a lower number on it. So it's gonna be 1 hexene. Usually, guys, when you have double bond in carbon 1, they don't emphasize on it because everybody is a rule that everybody knows that. But here they talk about it. So you can come up with some, when you look up on internet, you may come up with some sums that they don't talk about the 1 here. So you might see just hexene. That's the same, guys. So in some other books, you might see that they just write hexene here. They don't write down as 1 hexene, and it's totally correct. And what's the longest chain? So this is the longest chain, right? Because that's the most number of carbons inside it, and it also includes double bond in it. Then from which side I should start numbering? Here there is a little help, right? We should start from the right side because that's gonna reach my double bond sooner. So I should start from the side that reaches my double bond. So my double bond gets the lower numbering. So it's gonna be in my number 1, I have a double bond because I said that when you have a double bond between carbon 1 and 2, the double bond goes to the carbon that has a lower numbering. So it's gonna be 1 hexene And also we should talk about the branch, right? If I put the longest chain in the box, this branch, here we go, this comes out. So I should also talk about it. So this is the kid, guys, here. This branch is a kid. Do you know when you have a kid, your kid is comes first, right? Always. So the kid, always when we name the chain or this compound, always comes first. So we're gonna put 4-methyl as a kid first, then 1-hexene. What about the third one? Where is the longest chain, guys? Here is the longest chain. You might tell me, yes, the longest chain might be also this one or this one. You are for sure this is not correct, right? Because it has 4 carbon in it. But this one that I'm pointing now, 1, 2, 3, 4, 5, it can be correct too, because it has 5 carbon and also it includes the double bond. You are correct. But I decide to put the straight line because I like it, you know, as I'm just kidding. So we just put it here, a straight line, and let's see. So we know that the branch is a kid, so it comes first. So I have in carbon 2, 1 ethyl group, in carbon 3, 1 ethyl group. So it's gonna be in carbon 2 and carbon 3. I have 2 ethyl groups. So it's gonna be 2,3 diethyl. And on carbon 1 is gonna be pentene. 2,3 diethyl, 1 pentene. Let's go if you were choosing the one that we talked about at the beginning, this one that I'm pointing out. But if you, I want you to do it and name it. It's gonna be the same, guys. The same naming. I want you to do it and to come up with the same naming that we got here for that. Okay. What about, guys, if we had methyl here instead of ethyl? How we could basically start naming it, to write a name for it, if we had a methyl group here instead of the ethyl? Still, we would go numbering from the right side. Why? Because I reach my double bond sooner. But when I write it down, we make sure that first I go with the alphabetic order when we write it down. The same as for alkanes. We go with alphabetic order when we write down the name. So it's gonna be first the ethyl group and then the methyl group. Just head up for that. Okay, so let's go to alkynes. The rules for alkynes is the same rules that we talked about for alkenes. Okay, so you should make sure first you should start find the longest chain first, but the longest chain should include your triple bond. Okay, you can see that in here I reach the double bond sooner, so that I start numbering from the right, and here also I start numbering from the left because I reached the triple bond I meant here. So because I reached the triple bond sooner. What do you think, guys? If here I would reach the triple bonds the same, here 3, just imagine if I would reach the triple bond from the left side and from the right side the same, it would be in the same position. Just imagine what I would have started from the right side or left side. I would have started from the right side because I would go from the side which is more crowded, the same as I had with the alkanes. Okay, that's basically naming the alkynes. So imagine here that, as you see here, we have a 1, 2, 3 because the position of 3, we get a lower number on alkyne. When I start numbering from the left on this compound. But when I start numbering from the right, 1, 2, 3, and 4, this one gets number 4. So you can see that here I get the number 3 is lower than number 4. So I should start from the left side. Then, if you remember, we should start with branches first because they are alkenes. So it's gonna be 6,6-dimethyl 3-heptine because we should name from the lower the carbon that gets the lower numbering. Here the same because my branch is in the carbon number 3. I put 3-methyl and it's gonna be 1-butyne. Again, if you see in other books that they don't put, when there is a triple bond in carbon 1, they don't put 1, is completely fine. Okay, when you have 2 double bond or here, or maybe 2 triple bonds, you make sure that you end up with di-N because you have di means 2. It means that you have 2 double bond. But important thing is that the same rule that you had when you had 1 double bond or 1 triple bond. You should make sure that the long chain should have the 2 double bond in it. Because these are the parents now, you should make sure you cover it in the long chain. Okay, so this one, the second one also, guys, the parent should have the 2 double bond in it. Or if you have a triple bond, the parent should have also the 2 triple bond. Okay, guys, what about having compounds other than alkyls attached to our chain? For example, halogens. Here you can see we have chlorine attached to my chain. Whenever you have halogens attached, like here chlorine, you remove the INE from the end of it and add O instead of that. For example, chlorine becomes chloro, fluorine becomes fluoro, bromine becomes bromo, iodine we have iodo. Even when you have an NO2, it becomes nitro. So knowing that, whenever you have the halogens, for example, attached here, always make sure find the longest chain. As you see here, we find the longest chain. Then you should start from the side that you reach your halogen sooner, for example here, or you reach the one other than hydrogen sooner, which is chlorine here. So you should start numbering from the right side. So you come up with the name of 1,2-dichlorobutane. What about the second one here that has a bromine? For this compound, guys, again, I should find the longest chain, but pay attention, my longest chain that I want to find should have more branches on it. If I choose this one as the longest chain, I see that I have 2 branches on the longest chain, bromine and propyl. But if I find the straight line as the longest chain, this one that I'm pointing to, I have only 1 branch on it, which is CH2Br. So I'm not gonna choose the straight line as my longest chain. I'm gonna do the one that I'm already have a line around it as a longest chain. Which side I should start numbering from? From the bromine, the CH2 that has a bromine attached to it. Why? Because I reach the branch sooner, which is bromine. Okay, so it's gonna be 1, 2, 3, and 4, and 5. So it's gonna be 1 bromo, 2 propyl pentane. Okay. Now we come up with a cyclic compound. So what do you think would be? Chlorocyclohexane.